I'd like to welcome you to this lesson. And in this lesson, we're going to talk about working with matrices and vectors in Matlab. And so it is important to keep in mind that essentially when we are working in Matlab, that variables are represented as matrices. And what we mean by this is that we've discussed that variables are case sensitive and that their names can contain up to 31 characters and they must start with a letter. And when we talk about a matrix, we're talking about the representation with regards to rows and columns. And so a matrix can have a representation of one row and one column, one or four rows that are one column, one row that has four columns, two rows that has four columns, and many other different configurations that can be taken into consideration. And so with regards to a representation as a one by one matrix, we're essentially referring to a single element or a single vector that is used to represent. When we're representing a matrix as a four rows and one columns, we see that essentially we just have one column with elements stacked on top of each other to represent each different row in the matrix. When we talk about a one by four matrix, we have essentially one row with four different columns. And when we're talking about a two by four matrix, we have two rows and four columns for each row. And so when we talk about a vector, we want to keep in mind that a vector is essentially a representation of a one-dimensional array of numbers. And this can be done with the creation of either a row vector or a column vector. So in this case, what we have for our 4x1 representation is what we call a column vector, in that we have four different columns for our, or we have one column that encapsulate four rows. For a row vector, we have a row of elements, one row of elements that is four columns in length, or four different columns. And so we've previously discussed the schematics that we have associated with uh, assigning values to variables. These values are already stored in our workspace in Matlab. And if we were able to create, let's say, three different variables, myvar, myvar2, and myvar3, and we assign initial values to those, our output in Matlab would be as following for each one. Myvar would equal 3, myvar2 would equal 4, and myvar3 would equal 0.7500. So to get the pertinent information from Matlab, we could do the whos command, and this would provide us with an overview of the size of each variable, the bytes in memory that are being stored, and the class that they belong to. So this gives us three elements that has a size of 24 bytes. And if we want to see what variables are contained in our workspace, then we could simply do the who command, and that would provide us with the names of each of the variables that we currently have stored. And so this is a refresher on how we can assign variables, but how do we assign values to vectors? So if we want to assign values to a vector, and we want to do something such as create a row vector, we would name the variable for the vector that we want to create, And so in this case, we say A equals. Now on the right-hand side of the equal sign is where we will instantiate the values and assign the values for our row vector. And in this case, to create it, we will use the brackets, which are used to denote a matrix. And then we'll simply assign the values separated by spaces. So in this case, we're creating a row vector that contains 5 elements, 1, 2, 3, 4, and 5. In Matlab, it will provide us with the appropriate output that we need once we have created this vector. The same format can follow when we want to create a column vector as well. And so in the creation of a column vector, we're going to need to separate the values by semicolons. And this basically means that for each row, we only have one element. And so we'll create another row and then another row to provide for a column vector representation. So once this is executed in Matlab, we'll get our representation as follows. So it's important to keep in mind that there are various ways that we can assign values to our vectors in Matlab. One command that enables this to occur is the use of the Linespace method. And this method is useful because it allows for the construction of a vector of a given size with a specific number of elements, and you're able to identify the baseline for starting the elements versus the top level. So in this case, what we want to do is the method, the function Linespace will enable us to create a vector that is a size 100. And so what this means is that it's going to create a row vector that is 1 by 100 in size, and it will start with a value of 0, and it will go to the value of 2 times pi. And Matlab will determine the appropriate increments that will be used to determine what each value will be. So if we were to do this in Matlab, it will provide us with an appropriate output once the command is executed. So let's see how this would look in Matlab. So let's consider what would happen if we were to enter the command in Matlab. So we can declare our variable C1, and we'll use the Linespace function. And in this case, we're going to take in the starting value, the upper limit of values that we want our vector to contain, and the number of elements. And so now we have created those elements, and in Matlab, it provides us our vector and gives us the values that have been assigned to each of the values in our vector. So if we run the whos command, it shows us the name of the variables in our workspace, the size, the bytes, and the type that is being used. And so we're able to specify specifics for creating this vector. And so if we were to start with 0, go to 20, and then let's say we wanted to have a row vector of 1 by 50. And so as we see here, our starting element starts with 0. The last element ends with 20. And Matlab will automatically determine appropriate increments for these elements in between. And so now we have listed the sizes for the variables in our workspace, C1 and C2, the size for each one, as well as the amount of memory that is being consumed, as well as the type that is contained in the vector. So this provides us with how we are able to create appropriate vectors using Linespace in Matlab. In addition, we're also able to provide for some other implementations as well. So we can also multiply a vector by a specific value. And this will allow for us to construct an array of 100 elements between 0 and 2 pi. And in this way, we use colon notation to create those elements. And so let's talk a little bit more about how do we assign variables, values to matrices. And so in this representation, we have a 3 by 3 matrix. And what we see here is that we have each row that is represented and each column too. To represent for each row, we end it with the colon. And this will mean that 1, 2, 3 will be on our first row of our matrix. 4, 5, 6 will be on the second row, and then 7, 8, 9 will be on the third row. And therefore, if we wanted to continue with other rows, we could easily do that by adding another semicolon here and propagating it with the values that we wanted. So in general, this matrix representation and mathematical connotation would just be represented as 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 3 rows and then 3 columns for representation. And so it's important to keep in mind that columns are separated by a space or a comma, while rows are separated using the semicolon. And so we can also access specific elements in a matrix as well. So for example, if we wanted to access an element that is at position 2, so it's going to be on row 2 and column 3, then all we would need to do is enter the name of the variable or matrix. We'll use parentheses, the location of the row, and then the location of the column of the element that we want to access. So in our previous example, we had A is represented using this matrix. And so if we wanted the values at row 2, column 3, what we would do is go, this is row 2 here, and then this is column 1, 2, 3. And so the value that we pull from this matrix is going to be 6. Now, if we wanted to pull just the entire row of our matrix, the way that we would do this is that we would list the row and then denote it with a colon as well. And so here we have 1, comma, colon, and then it will provide the first row of our matrix. if we wanted to list the last column of our matrix, then what we would do is we'll have A, and then parentheses, we'll have colon, comma 3, and this represents pulling the last column in our matrix, which contains the values 3 on row 1, 6 on row 2, and 9 on row 3. We can also consider if we wanted to pull appropriate data for just a row that is different from what we previously did. So if we wanted to access row 2, we can pull the values that are in the matrix by using A, 2, comma, colon, and this will pull all of the values in our matrix that are contained on row 2, which includes the scalar variables 4, 5, and 6. And so this is just an introduction to some foundational topics that we can use to understand how vectors and matrices are represented in Matlab. Let's also just take a look at a few different examples to apply how these can be used in action. So let's consider if we want to create a few more different elements. So we've talked about how to create row vectors, and we've also talked about how to create column vectors. So let's just practice the creation of these aspects on our own. And so let's start with my row vector. And if we want to create it, we'll name it my row vector. On the left-hand side of our equal sign, on the right-hand side of the equal sign, we will declare the elements that we will contain in our vector. And so in this case, we'll say 10, 20. And so in this case, we created a row vector with various elements in increments of 10. And we could start with the first one being 0, actually. And so this contains our row vector that has the elements 0, 10, 20, 30, 40, 50, and 60. Let's also create a column vector as well. So we can say and so if you'll want to recall about the column vector differentiation is that in between each value or in between each row, we will use a semicolon to denote a new row. So if we wanted to create a column vector containing only one element for each row, then we would do and we will do this in increments of 5. So this creates our column vector and provides the output once we have executed it appropriately in Matlab. And so when we run whos to see what the contents of our variables are, we have my column vector. It's a 7x1 matrix. 56 bytes are being used. It's size double. And then for row vector, we have 1x7, 56 bytes are being used. And again, it is a class double. And so again, we can also consider how can we reference specific elements in our vector. So let's say we are in my row vector. Or my column vector. And we want to access element 4. Then that gives us the answer of 20. And it gives us the answer of 20 because element 1, 2, 3, 4 is what is represented here. And so let's say if we wanted to create a smaller version of our row vector. In this case, we would do what is called a subvector. And so if we wanted to pull out specific elements of my row vector, and so let's recap what is contained in my row vector. We have scalar elements from 0 to 60. Well, let's say we just wanted to create another vector that only contains the first 3 elements of my row vector. So we would create a new vector called my sub row vector 1, and it is going to equal to my row vector, and we're going to just pull specific elements. So we'll want to start with the first element, and we will say from 1 to 3 is going to equal my row vector. And so what this does is creates another vector that it contains only the first 3 elements of my row vector. Now, if we wanted to create another vector or another smaller subvector, we can say my sub row vector 2 is going to equal, and we will say 4, 5, 6, 7. And so now we've created another vector that contains the last part of our original row vector. And so let's see what elements are contained in our workspace now. Okay. And so now you see that we have our vectors that are listed here, and then our new subvectors, and it shows that it is a row vector 1 by 3, and then a row vector of 1 by 4. And you'll notice that for each additional element that is added, that there is a increase by 8 bytes for the total amount of memory that is required for it. So this allows for us to see some initial operations that can occur when we are creating row vectors, column vectors, and matrices in Matlab.